Hello everyone, this is Book Developer Circle Moscow. My name is Sergey Astebov. Today we will have another webinar related to web technologies, and we're going to talk about TypeScript. The Russian version of this webinar available via link in the description. Let's start with some information about TypeScript. The first version of TypeScript appears in October 2012 after about 2 years of internal developer at Microsoft, and the current version now is 4.2.4. This language goes under the Apache 2 license, and usually you write code related to TypeScript in TS or TS6 files. You can search for some information about TypeScript documentation and some available packages on typescriptlink.org. This language was influenced by C#, Java, and of course JavaScript, and also influenced some languages such as ECMAScript and AssemblyScript. Basically, TypeScript is an addition to ECMAScript 6 that adds several useful features like typing and other stuff that we're going to talk about. So why do we need TypeScript? We can simply write our code in JavaScript and maybe use some JSDoc to add some typings. And why we should bother with other languages? And if your project is small, simple, or you work alone, like you can remember all parts of your project all the time, it's okay. But as soon as your project became like complex enterprise level, it contains hundreds of files or several developers or even start working on it, it became very difficult to maintain such things. And it can be even worse if you inherit this project in such state. I had this experience and also give some presentation in Rumble Frontend Meetup when I talk about project and how can you use TypeScript to actually make your life better in this condition, but unfortunately it's only in Russian with some subtitles. Maybe I will add link to this meetup in description, but yeah, I'm not sure. Other thing that people usually afraid when we think about TypeScript is that it will make development process really complicated and it will be impossible to move code base from JavaScript to TypeScript, or it will take just huge amount of time. But beauty of the TypeScript is that it's provide non-serious typing and it's backward compatible with JavaScript. So if you want to move your current code base to TypeScript, you can basically just transpile files gradually, just changing files one at a time. The same things go to typing. You can use several types for some reasons, or for example, if you're not sure what type goes for some particular variables or arguments, you can just use any and maybe switch to some more specific type later. Also, you can set your type lint to avoid any in your project without a specific restriction to disable type check for a particular line. Usually it's the case, otherwise you will just like add types to your project without adding anything. And yeah, basically, so if you want to move your project from JavaScript to TypeScript, you can just remain extension of your files from JS to JS, and after that apply any or specific types if you know where a particular type should be. And after that, just write new code in TypeScript and gradually rewrite old code from JavaScript to TypeScript. Another question which people usually ask when you think about TypeScript is that if you can run this code directly in browser without any transpilation, but unfortunately, at least for browsers, it is not possible to run anything besides JavaScript or WebAssembler right now. And as I know, there is no development of new engine like V8 for TypeScript particularly. And if you talk about Node.js, there is a TS Node, but I think most likely it also uses some transpilation under the hood and just transpile code from TypeScript to JavaScript and run it as is. Maybe there's some development goes on. I'm not sure. If you know anything about this issue, please leave a comment or maybe contact me directly, because it's a really interesting case. Can you run TypeScript directly in browsers or Node.js or anywhere else? So how to use TypeScript? There's a few simple steps. First of all, you will need to install TypeScript in your project or globally. After that, you can run transpile for all projects just through npx tsc or to some specific files, or you can run compile with some configuration. Besides that, you can specify tsconfig and also apply some compilers in your build pipeline, like for Webpack or for Gulp or for whatever you're using. You can read more about tsconfig via this link, about some settings for test loader for Webpack, and about some general stuff, how you can actually configure your project for TypeScript and for other checks via these links. I will add this link to the description, and what goes about this link to article for LinkedIn, even faster single page application. I wrote this series of articles a few years ago. Maybe it became a little bit outdated, but you can get like main point from it and maybe set some environments in your project, like for TypeScript compilation, for security checks, and for other stuff. Just if you have time, it's nice thing to read, I think. Now let's move to actual TypeScript stuff. TypeScript has the same types as JavaScript, for example, strings, numbers, booleans, objects, undefined, and nulls, as well as some interesting type related to TypeScript itself, for example, void. Voids, it's type like null or undefined, and basically it's used for a function that doesn't return anything. Other stuff is any. We already see some any and talk about it. So any, basically it's like any type of data. If you specify variable or argument as any, you can pass any value in it without any problem from TypeScript compiler or TSLint. Another type specific to TypeScript is never. Never, it's strange type which also apply only for returnable value from function, and you can specify the type for a function that doesn't return anything. For example, if it throws some error or if it's an infinite loop inside, so basically it's never terminate. In this case, this function will return never. And the last type like this is unknown. Unknown is like any, so you can basically write any stuff to variable or argument that specify as unknown. But if you have variable indicated as unknown type, you can pass this variable to either variable that has unknown type or to argument that has unknown type. Otherwise, it's the same as any. So yeah, you can apply type for variables, basically just write const, let, or var, name of your variable, commas, and then type. Also, if you add default value to your arguments, or if you specify value when you specify variables, you can omit type. In this case, type you'll get from value. For example, if we just write let something equal to hello world, the type of something variable will become string by default, because it will get its type from value hello world. For a function, you can specify the same argument. So basically, it's a function, name of the function, and then in the brackets you specify type. You specify arguments, types, and at the end you specify return type. As we said, for a function that doesn't return anything, it's return void. And the same case goes for never. So if your function throw an error or have some infinite loop, it will return never. Also, would go for any and unknown. As I said, for any you can pass anything. Also, you can pass variables that specifies any to anywhere. If it's specified as unknown, it means that you can write anything to this variable, but you can pass it to other unknown variables or other unknown arguments. Besides that, you will get compilation error or TSLint error. Now let's see how we can actually apply types to the variables. Yeah, as we see before in small examples, you can specify a variable like use let const or vars and name of the variable, commas, and then type. For a function, it goes the same. You can specify attribute, then types, and after brackets you can specify a return type. Besides that, you can use question mark. In this case, it means that a variable became unnecessary, so it's equal to this type. Like for counter caps, we can pass a value which raise a Are they going to be string or undefined? So we basically can call count cups without any variables. Another interesting case, when you use vertical line, you can use it in any place when you specify type. It means that when you specify several types separated by vertical line, it means that variable or arguments or return type should be one of these types with separate line. So for this example, our function get value should return number or nil. And if we check what's going on in result section, first case, if we specify some variables and to vertical line and nil, it means that we will return nil if val is resolve falsy. So basically, if it's a 0, if it's a false, if it's undefined, and so on. And the second case, when there is a val to question mark and nil, we will return nil if val only null or undefined. So if it's false like null or like null, we will still return null. If it's null or undefined, we will return nil instead. Another interesting question relates to this assignment statement. So there's 3 examples. First one is ampersand. If we set 2 variables a set to nothing, b set to 1, and after that we try to rewrite or assign new variables to a and b using this statement like 2 ampersand equal. Then we will assign new variable only if current value is truly. So it should be non-zero, not false, not undefined, so on. In this case, a will still be undefined because it was undefined before and it's resolved to false, so we does not overwrite with default. We will overwrite b because it was 1 and now it's resolved to true, so we overwrite with 5. Another example where it's b equal to 0 and we use question marks. In this case, we will assign new value only if current value is null or undefined. So for a, it was undefined. After this assignment, it will become default. For b, it was 0, so it was resolved to false, but it's not null or undefined, so b will remain the same. We will not overwrite with 5. And the third example, when we use 2 vertical lines, we will only assign current value if it's resolved to false. So for a, because it was undefined, it resolved to false, we will overwrite and set the false to default. For b, it was 1, so it resolved to true. It means that it will still be 1. If, for example, in this case, we will set initially b to 0, and use this assignment with the vertical line equal 5, we will overwrite b, but because in this case b was 1, we don't overwrite anything. Next, let's see how to specify type for object. Basically, we can use the same object literal, and inside it we can specify types for every property, just the same as we do for arguments or variables. Also, we can use question mark to specify if some property is not required, and use some additional words to specify like access type, read-only. If we use read-only for object, it means that this property cannot be right, but it's gonna work only for TypeScript. I'm not sure if during transpilation it actually adds some new code like define property or something which made write or false. You can do this in JavaScript, but as for transpilation, I think it just check static property, and that in TypeScript no one try to actually write in this read-only property. Besides that, it will work the same in JavaScript as without read-only. So if you need to make sure that you don't write anything in your property, use it by hand, use object-defined property or something, or some checks like setter and getter to avoid some writes in your property. For type check, you can just use write only. Another interesting case goes for like list type. So you can basically specify some types for object keys and values. In this 2 example, First, we specify that we will use only strings for keys. Like if you try to access your object dynamically and pass variables, you can pass only string to accesses. If you will pass number or something else, it will throw you an error. And second case, we specify the keys is numbers. So basically, you can use only numbers to dynamically access object. Under the hood, we will still use strings. So if you pass like your object and square brackets 0, it will convert 0 to string and use as a string property. But for type checks, it will require only numbers. And for both cases, we specify that our property values should be types. It's basically our own type or interface or class or whatever. Instead of types, we can also use like string or something to specify that our properties can be only string in this case. But yeah, you can use whatever. You can use the same types and like question marks and vertical lines and everything else that we use in other places you can use to specify property value here as well. As for arrays, you can specify it in two ways. First, it's a type and then empty square brackets. Otherwise, you should write keyword array, then angle brackets and type. As for multi-dimensional array, you basically just write array in array or multiple square brackets like this to specify if you have matrix of strings. I think first type is preferable. Arrays with angle brackets only used for some fancy stuff where, like for example, when you have array of promises, then you will probably should use array with angle brackets, otherwise it would be hard to specify type is square brackets, just because your type became too long to really understand. So yeah, maybe in this case you will should use array, otherwise you will probably use just square brackets. Another thing is tuples. So tuples, it's basically array with some fixed length. Like in this case, my tuple is basically an array of 3 elements, and each element has its own type. First one should be string, second one is number, and third one is optional, and if it's specified, it should be boolean. Another interesting thing is it's a separate operator for types. So basically, we can declare 2 tuples. First one is contain 2 elements numbers, second one contains 2 elements strings, and after that we can specify another type and use spread operator, so basically to flood all these types and get another tuple of 4 elements with 2 numbers and 2 strings. Besides that, we can also declare our own types through type keyword or declaration keyword. After that, there's go name of our types, and as a value it can be other types, it can be tuple or whatever. In this case, we specify our own type vector 2D, which is a tuple of 2 elements. And after that, we use this type in arguments, as we did with any other type before. Last thing that you can do with type, you can actually specify as type correct value. So for example, in this case, direction, it's not just string, it's either left or right, and roll, it's not number, it's 1, 2, 3, 4, 5, or 6. In this case, it will probably better to use enums or something. We will check how to work with enums later, but yeah, you can also use just some value to specify instead of using type. Now let's see how use types with function declaration. Basically, for this way, when you specify function name, or if you write function in some variables, you basically just write function names, and there's arguments. For each argument, you can specify type. You can specify if it's optional not with question mark. You can set default value, and after that, after curly braces, you can specify type for return value of this function, like we did with any, void, never, and so on. Also, as I said, we can use question mark to specify if some arguments is optional, but we cannot like use non-optional arguments after optional. So for the second case, there will be error because we specify argument first is required, argument n is optional, and argument m is required. In this case, if we use some optional arguments, it means that all arguments that goes to the right of optionals also should be optional arguments. We can use spread operator commands. It will be equal to some array, so we should specify type of array of something. Also, we'll probably can use like tuple, but we should make it optional. And also, if you use like this, if you use tuple for spread operators, it means that you will not be able to pass more arguments that you specify in tuple. Besides that, it's fine. Also, you can use default values for arguments and emit types. So in this case, we specify that args by default equal to default, and we don't write that it's type string because it's just get type from string default. For arrow function, it's the same as for regular function. The types and go return types and arrow and function body. If we need to specify this in some case, then as a type we will going to use just class name. For example, if you have class and some method in this class, and as an argument you get a pointer to this, as a type you will use just the same class name. Also in TypeScript you can override some function, just declare different function with different types, like this. So for example, if cone gets a as a string, it will return number. If it's gets number, it will return string, and if it get string or number, it will return string or number. We can also use like conditional types in this case. We will check it later. I'm not sure about any like practical application for this example. Maybe if you have like weird function which convert string to number and number to string, you can use conditional types, but yeah, I'm not sure where you can actually apply this overriding or conditional types, but we will see some examples. Next thing that we're going to talk about is union and intersection type. As I said, you can use vertical bar to specify several types, like for code and for empd. We said that it can be string or number, so if later we will write some value in this variable as number or string, it will be okay. If we will try to write something else, we will get compilation error, and also we will get error from your the TypeScript lint if you set it for a project. But yeah, if you try to compile this code in JavaScript, you will get an error if you try to write something else besides types that you specify. If you do the same with classes, it became more interesting. For this example, we specify two interface, bird and fish. They have like the same method lay eggs, but fish has a swim method and bird has a fly method. Then we declare if function get small pet, which will to fish or bird. Then we get pet and call for lay eggs method, and everything fine because both classes has this lay eggs method. But as soon as we call for swim method, we will get some error because if, for example, our get small pet will return bird instance, we will not be able to call this function because bird doesn't have it. In this case, we need to assign pet to specific type or just add some checks. We will see later how to do this. But yeah, if you just write this code as this, you will get some error when you will try to compile this code in JavaScript. The same goes for union. So basically, if you declare some interface error handler with required property success and optional property error with equal to object with one property message, then if you specify @works data and artist data with two properties, artists and artworks, which is array of object with title or name. After that, we specify type @works response, which will contain properties from both type from @work data and from error handler. So it will has required property success, it will has required property artworks, and also optional property error. In this case, yeah, we can specify response like this, and it should work fine. Yeah. So if you use union, we basically just like physically combine two interfaces and use same property. I'm not sure what will happen if, for example, interfaces is not compatible. For example, if we will have artwork with optional field success and error handle with required things, required property success. If you try to unify those two interfaces, you'll probably get some error because they have different definition of success property. But if they like have the same thing, for example with bird and fish, if we try to unify them, we will get some interface which has three required methods: fly, swim, and layX. And because layX has the same definition in both interfaces, it should be fine. But yeah, if you try to unify some, it should be sure that you can actually do this. We see some way how we can actually create our types with types and with declaration, but if we try to specify something more complicated, we will probably use interfaces. Interfaces work the same as in other languages, so we can declare interface, we can extend it from multiple other interfaces. After that, we can specify properties as the same as we did with object. And after that, we can use those interfaces with class declaration. So basically, we can write some class name, extend it from other class, and after that, set that it should implement one or several interfaces. In this case, every required property should be specified in class as well. Like for our case, it's property and probably some properties in parent and some classes. Every optional property can be omitted, but if you specify optional property as well, you should match types. So for example, if we specify optional method in our case, we should make sure that it has argument y1 with type equal to type. Otherwise, we will get some errors that our class is not actually implement all properties in interface. Another thing that we can do, we can specify enum. Enum basically is just array of constants. If you don't specify any value, it will be just array of constants with value equal to 0, 1, 2, 3, and so on. Or you can specify some values like with color example. And usually use this stuff to avoid some spelling problem or just avoid copying the same string multiple times. Also, you can use enum as a type in value or in arguments or whatever. And in this case, you'll be sure that you can get only this particular list of constants as a value. You can also add some checks, but yeah, usually just add some constants in enum and use like options dot enum property name in your project to avoid any problems with changes or spellings or with cases when you actually get some arguments that it's not in your enum list. Yeah, and last thing that we already see, it's name type. So basically you can just specify type or declarations and create some name, and after that set it to some other type, some union type, some specific variables, some other stuff. So basically to any type. Usually you will use this stuff to declare some complicated types, like for, in this example they specify type point, and after that they just use this type point in all places that they need. And yeah, sometimes you can specify interface or type. Usually if it's something small enough, you will specify it as a type. If it's a huge declaration, you will use interface, and usually just declare your own data type in this way to avoid copying the same huge like type declaration as an object in multiple places. The next thing that we're going to talk about is generics. So for example, imagine that we have this method getArray that gets some array and return new copy of it. Then we call this method passing the number array and string array. and everything seems fine, but next we can actually try to push some non-compatible type. Like for number array we push string high, and for string array we push number 500, and it will work fine. And probably it's not something that we want, because if you pass array of numbers, you expect that you will get also array of numbers with some type checks. And to do this, we can actually use generics. If you use generics in Java, it works the same. If not, you can do this like this. So basically specify function. After function name, you use angle brackets and write there one or several variables that you will use for types. So in this case, t is just a variable name. You can use anything else, but just convenient, like I in for loop. The same goes here. You just use t for types. After that, you will use this type in all cases when you need dynamic time. So in our case, we just replace any with t, and also we pass this t for array, because array also supports generics. After that, when we call this function, we also pass types in angle brackets. And after that, if you try to push some string in number array, you will get error. Also, as I said, it's just in generic, it's just a list of variables, so you can specify as many as you want. You can also set that they extend something. For example, in this example, function display has one generic variable, and it extends person. So if you pass anything in this generic, it should be like it should be person or any class that extends from person. If you try to pass something else, you will get an error. Also, you can set like default types for generic variables and so on. So basically, the same thing that you can apply for other places, like arguments or variables, you can use here as well. Now let's just summarize something that we already talked about and try to specify interfaces and generics for generator. It seems complicated, but it's actually not so hard to understand. First of all, you're going to specify interface for iterator, which gets 3 variables in generics. First one will be specified in any case, then t result, which by default equal to any, and t next equal to undefined. Then we specified 3 methods. First, it's required next. It will get some arguments and return also iteration results. Plus, in this case, we can pass our generic variables in some other interfaces that also use generics, as we did with interface result. Also, we specify some optionals method like result and throw. After that, we specify interface for generator, and we extend this interface from iterator. Also, in this case, we just pass generics from generator interface to iterator interface. In this case, we declare next function, but we can actually emit this because it's the same, and because we just extend interface generator from iterator, we can emit next. But yeah, for some reason they add this in this example. Then we declare result and throw methods, and something that we should do because we want to make them required, so we have to declare this. And the last thing, we declare some additional method using simple point iterator. We need this to make sure that our generator that returns this generator interface will work properly with for off statement. If you don't pass this iterator and try to compile this code, you will get an error. So yeah, if you want to write like proper generator, you should also specify this simple interface or extend your generator interface from actually existing interface, existing iterator interface. We just specify this for example, but you can get all these interfaces from like existing packages without need to specify everything by yourself. Next, after generator will specify type of iterator result. It will return yield result or return result. Yield result contain optional property done and some value, and the return result will contain done and also required property value. Then let's see how to use this interface. So we specify some generator counter, and then we set that it will return interface generator and specify 3 types for generics. So first we specify number. It means that our yield value will be type of number. Our return value, like last value that we return, is string, and we specify that we have to pass some Boolean value in the next statement to get next value. So after that we just create this counter, count for next, and count until it equal to 5, and yeah, everything works fine. Also, you get proper interface. You will get some suggestion when you use value from this counter that will suggest you that you will get like number value from generator or string variable from the last case, and so on. Yeah. Just the case that you don't really need to like write all of this interface by yourself. You can use existing interface or existing packages, but we will talk about this later. Now let's talk about some other stuff. It's indexes, mapping types, and conditional types. So for some cases you can create type like pointer, specify different properties, and after that you can specify other type or just set its type using kof. In this case, it means that point property can be equal only to some properties name from point. So basically, it's just x or y. If you try to specify anything else, you will get an error. You can use the same construction in generics. In case when you use list, you also can use kof, but you need to use in kof. And it will work the same. So basically, if we specify some type and set that it equal to object with key, where key is in kof pointer, it means that we will be able to create object with maximum 2 properties, x and y. And to do so, we can specify like this: p in kof pointer, and so on. The next thing is conditional statement. So as I said, for overriding example, we can do the same with conditional statement. In this case, we declare our swapper type. It uses generic, which extend number or string, so it will accept only strings and number, and then it will return type based on what type it gets. So if it gets type that extends number, it will return string. If it gets something else, it will return number. The first statement equal to these 2 cases with override. So if you get value with type number, you will return string. If you get value string, you will return number. And for mapped class and conditional statement, you can use the same in type and interfaces. I never see this in practice, but yeah, it's something you can do, and maybe for some weird cases you can apply it, but it's not something that you will see or maybe understand that easily, because yeah, you have to spend some time to understand what's going on in this string. Next, let's talk about some type assertion and type guards. So if you get some variables of any type, or you can get some variables from outside of your TypeScript code, you can actually assert its type to some particular type you need. You have to write like your variable name as and type that you want it to become, or you can write the same using angle brackets. Another weird case, what you can do, you can specify variable using let or var or whatever, but you can say that its value is a constant. So in this case, we basically said that point value, this object with x and y, is immutable. You can change value of pointer for anything else, but you cannot like change value of x or y, or add some properties or remove some properties. So it might be useful when you need actually value to be immutable, but to be able to change value of your variable itself. The next thing is also some weird stuff related to checks. Basically, you can add some logic in your TypeScript code. For example, you can specify function these things which get value of unknown type, and it will return true or false based on if value is thing or not. So inside that function, you will probably use some instance of or something else to do this check, but you can also add this check in TypeScript and change your logic. Also goes for like declaration value, string or number. If it's number, it will run one code. If it's string, it will run another code. The same work with instance and with woof in pet. For example, this example that we had with birds and fish, we can add some check like this. So if we have this swim method in our pets, and we can swim, otherwise we cannot. I think if you try to transpile code like this, it will generate the same JavaScript with check for like type of or so on. But yeah, it also something that you can use in your code to base your logic on types. Now let's see for some utility types, so some words that you can use to generate types based on some logic. First is partial. You can use this partial angle brackets and pass some object, and it will return new type where all properties is optional. The same goes with read-only, so you can pass some object, and as a result it will return your new object where all properties is read-only. I'm not sure if it's actually do like deep copy. For example, if you have some property which also equal to object, I'm not sure if it's actually going to change this property value to read-only object. Probably not, but yeah, it's something that you can check. Next one is pick. Basically, you can pass some object and pass a list of property names, and it will return a new type which includes only properties that you pass. Next goes record. So basically, you can create some object with from list of properties and said that all these properties would be equal to second type, like in this case number. Next case is exclude. You pass some list of types and other list of types, and it will return you new list of types which is different between two lists. Opposite example of this will be extract. Basically, it will return just a union, or it will return the intersection between two type lists. In this case, we have string and both lists, so it will return string. Next one is return value. It allows you to actually get some time based on some function result. In this case, they just use some dummy arrow function, but yeah, you can use some function with some logic and so on. And the last one is instance type. It allows you to get some type from class or from instance. Now let's talk about decorators. Decorators actually allow you to add some logic to function, properties, arguments, and so on. In this case, you have two decorators, first and second. You call them using this ampersand ones and name of decorator and brackets. We can actually call decorator without brackets. In this case, we should specify decorator as a function that we return. But yeah, you can call decorator with brackets if you want to generate some logic, for example, increment some counter, or if you want to pass some properties in your decorator. In this case, you can use brackets and pass some values when you call for decorator. Otherwise, you don't really need this construction when you have decorator functions that return decorator itself, and you can just call decorator without any brackets. Then if you talk about decorator itself, the function that return, it will get 3 arguments because we apply it to class method. First one will be target. It will be just class in which we call the decorator. In our case, it will be example class. Then property key in this case will be our method name, so basically just string method. And the last argument is decorator. It basically just property decorator for our function. We can change it or we can return new decorator. For example, for some bind decorator, it will look like this. In this case, we will call this bind decorator without any brackets. As a result, we will return new decorator, set configurable to true, and set some getter, in which we will specify our descriptor value. So basically, we'll going to set this context to return function, all this to some value that we want. Maybe we can write this bind decorator easier, but yeah, just some examples that you can find online in some npm packages. Another way where you can actually use decorator is in class. So you can call the same for class, for function. You specify decorator. In this case, they call decorator without brackets, so they just specify decorator as a function without return another function. If you apply decorator to class, you will get as arguments class itself, and you can change it, or you can return another class based on it. So, for example, if you can create some decorators that will return dummy class, you'll create decorator, you will apply it like this, but inside the decorator you will just return some empty class. If you do so, you will basically redeclare any class for which you're going to for which you apply this decorator. Another place where we can use decorator is for properties. In this case, they use brackets again, and they pass some parameters inside. Yeah, I'm not sure what's going on here. Probably they just print print this greeting in a format that is specified in decorator each time that they set some or get some values from this property. And the last place where you can use decorator in some arguments, they use some decorator to make sure that property is required. If you want to read more about decorator or write some decorator by your own, you probably should check documentation, because there's a lot of details and a lot of stuff that you can miss. If you want to use decorators, it will be better to check some documentation and check some specific for different cases, depending on where you want to use the decorator, or maybe to check for some side effects. Yeah, and the last thing that I want to talk about is actual types. We show different examples, some huge interfaces, some stuff related to decorators, and in most cases, if you will work on some huge project, you will not define those types and interfaces by yourself, because they all already existed. For example, if you use React, you can just install type/React package, and it will contain all types for React classes like React elements and so on. In some other cases, you can use just Google to search for some existing interface, like for service worker or something. You will probably find like what you want, or just find something closer to what you want. You can just change it. You will only define classes and interface and other stuff to something that highly specific to your project, like your own data types and object, for example, for your API. Besides that, everything already exists. I will also add some links to package search in TypeScript.org and to this define type repository. Then you can check existing types, or maybe even push or create pull request to this repository and add some types by your own. And that's it. If you have any question or any additional information, please write a comment, or don't forget to like this video and share it with your colleagues, and don't forget to subscribe to our channels so you don't miss any other webinars and meetups. See ya.